Alright, this is the fourth part, the fourth video. I'm going to do 3 more examples in this video. This last example, we just solved an exponential equation. We just got the exponent, or the x, out of the exponent and approximated it to be 2.289 using logs. Alright, that's awesome. Alright, let's move on. So this is part C, continued. Alright, so fourth example, here we go. Fourth example. Alright, so here we have the x in the exponent again. The x is in the exponent again. So I'm going to anticipate using some sort of log to solve for x. I'm also going to anticipate using the natural log. I'm going to anticipate this using the natural log. So I'm going to say solve using ln, natural log, because the base is e. Alright, so remember that the natural log is just the same as log base e of x. So if the base is e here, might as well use natural log to solve it. Alright, so first thing I want to talk about here is, if I can do algebra before I use logs, I need to. I need to do as much algebra as I can. So in this case, I want to divide by 8 before I start using logs. All right, I want to get the 8 out of there. It's an easy algebraic step, and it really isolates the exponents. All right, so 12 over 8 is 3 over 2. And now I've got just e in the exponents. Now I can take natural log of both sides. Whoops. Got to take natural log of both sides. It's okay. That's legal if I'm doing the same thing to both sides. That's algebraically okay. All right. So what's nice here is the natural log and the e, in a sense, cancel out because the bases are the same. Because natural log is log base e of x, and if the base of the exponent is e, they cancel out. So this just leaves 1/3 x, and this is just natural log of 3 over 2. And now there's an easy way to solve for x. If I'm dividing by 1/3, that's the same as multiplying by 3 on the other side. All right, so I'm going to figure that out on my calculator real quick. 3 times natural log. I'll say 1.5 to make it easy. There we go. 1.2164. So this is approximately 1.2164. Beautiful. All right. So we use natural logs there because the base was e. We just solved another exponential equation using logs. Amazing. All right. Let's do example number 5. We got 2 more here. Let's cruise through these. Let's see here. 2 plus. I'm trying to do different types of examples, stuff you'll come across in your homework. Alright, so just like last time, I want to do as much algebra as I can before I get to the log or the exponent. So here I could do a lot of algebra before, or 2 steps of algebra before I start solving for x. Subtract 2, subtract 2. So natural log of x plus 4 is equal to 4. Divide by 3, divide by 3. Alright, so natural log of x plus 4 is equal to 4/3. Alright, so we're going to do the opposite of what we did last time. So if I have natural log of something and I want to get rid of it to get to my x, so here you see I had an e, so I took the natural log. Here's the other way around. If I have a natural log, I'm going to raise it to the e to get rid of it. I'm using e because natural log is log base e. I want to make the bases the same. So if this is log base e, I'm going to raise it to the e. If this was like log base 3 of x plus 4, I would use 3 as the base. Alright, so I do that because in a sense they cancel each other out. So x plus 4 is equal to e to the 4/3. And now I just, by subtracting 4, I've got x solved for. Easy enough. There we go. Piece of cake. Alright, so in my calculator, actually, I'll show you how to do this in the calculator. Whoa, whoa, whoa. What's going on, people? Alright, there we go. No. There we go. Alright, where'd it go? I'll go into this. Alright, so it's e to the 4/3 minus 4. Alright, so e is second natural log. Crazy. E to the 4/3, I believe. Minus 4. Negative 2.063. Alright, there we go. It's approximately negative 0.0, what was that? 2063. 2063. There we go. Alright, so we just solved the natural log equation. Alright, last one. Let's cruise through this. So this is example number 6. Alright, and this is a good one because we're going to be using the product rule in this one. Alright, so natural log of x plus 4 plus natural log of x minus 1 is equal to 2 natural log. It's equal to 2 natural log of 3. Alright, here's what I see here. I see, I'm adding 2 natural logs together so I can combine them into 1 natural log by using the product rule. Also, on the right side, I can use the reverse of the power rule to make this a natural log as well. So here's what I mean by that. These can combine into 1 natural log just by multiplying the 2 insides together. And then I can use the reverse of the power rule and write that 2 in the exponent. Alright, so the stuff I used there was I used the product rule on the left side, and then I also use the power rule as well. And the reason why I did this is now that I have natural logs on both sides, so that 1-to-1 property says that x plus 4, x minus 1 is equal to 3 squared. That was the 1-to-1 property. All right, and this is a quadratic equation that we can solve. All right, I've got x squared using FOIL, x squared plus 3x minus 4 equals 9. Subtract 9, x squared, I want to set this equal to 0. All right, and to save time and space, you can't factor this. You're going to have to use the quadratic equation or the quadratic formula. I'm not going to do that here. To save time, you guys can figure that out. But what you'll get is, this is interesting. This is what we have to go to. All right, so through the quadratic formula, you're going to get two answers. All right, because it's plus and minus within the formula. So we get negative, we get 2.4051 and negative 5.4051. All right, here's the key though. Remember, our domain for logs is inside the log. Inside of the log has to be positive. All right, and if I plug in this into like that natural log, that's going to be negative. This is not a solution. It's like an extraneous solution. This is my solution. All right, so I plugged it back in, made sure they work, and that second answer, because it was negative, it was not in the domain, so it's not a solution. All right, our examples are done.